Okay, everybody, let's try and do a couple of questions. So, looking at the first one, we have to recognise which of these half equation is oxidation and which one is reduction. So, just having a quick look, we've got the three methods of working out which is which. The three methods are: can I see oxygens going up or down? Can I see oxidation numbers? Do I need to work them out? Or can I see electrons? And in this one, it's quite obvious that I can see electrons. So electrons are in all of these. So just looking at these, you can see which side of the arrow, if they're products or reactants. And I can hopefully be able to see that straight away if I go with oil rig cat. Hopefully I can see that when the electrons are on the right, when they are products, then they are lost. So the first one is oxidation. The second one is oxidation. The third one here, it is gaining the electrons, so that's reduction. The fourth one, it is the lithium lost the electrons, so that's oxidation. Pen's gone. Oxidation. Down to the fifth one, we've got it gained, this SN4 plus gained these electrons, so it's gaining, that's reduction. And finally this one, zinc 2 plus gained these electrons, so once again we've got reduction. So a really good, nice, easy from the textbook. This is an example of just having a look and instantly spotting whether it's oxidation or reduction. One of the three methods that you might use if you want some more goes on this one. There's some more questions on page 106 of the Heinemann textbook. Check it out, have a go, get in contact if you're struggling with that. Let's go on to the next one. Ooh, lots and lots here. Having a look at this looks like a bunch of questions. We might do one of kind of each. So the first one is the oxidation number. So we're using the oxidation number method here. If I look at, let's do maybe the first one and the last one. If I look at CO, it is neutral. It's going to add up to 0. The one that I know off the top of my head is -2. Therefore, that means C must be a +2. So in this case, the oxidation number of carbon is +2. Just to give us some space, I'll jump down to the last one here. This one looks a little bit harder. I've got CO3 and it's a minus. This is an ion. Given it's an ion, it doesn't add up to 0. This one adds up to -1. In this case, the ones that I know, that I recognize hopefully, are that O is a minus. O is a minus. You can do it. O is a -2. There's 3 of those, so that's -6. I don't know C. In fact, the question told me C is the thing I have to find, but I do know H. H is a plus. So if I've a +1 and a -6, and the whole thing has to add up to -1, hopefully you get that that is going to be +4. Now I know that we said that carbon before was +2, and now it's +4, but that is the whole point of oxidation and reduction, that these oxidation numbers will change. We'll skip question 2 just because of the lack of room. If you've got any problems with it, let me know. For the oxidation, let's go down to number 3. Find the oxidation numbers of each element. Let's just pick some random ones. CaCl2. So it wants us to find the oxidation numbers of everything involved. Once again, it's going to add up to 0. The one I know off the top of my head should be chlorine. He's a -1. There's 2 of them, so that's -2. That means that the chlorine is going to have to, the calcium is going to have to be +2, given that there's a +2. So the 2 oxidation numbers involved are calcium is +2, and the chloride part of it is -1. -1, not -2. There's 2 of them, but there is -2. This last one looks big and horrible, so why don't we have a crack at that? K2Cr2O7. Once again, it adds up to 0. What do I know? What do I not know? Okay, the one that jumps out at me straight away is -2. There's 7 of those, so that's -14. Wow. Chromium, I don't know. But I do know potassium K. Potassium K is in the first group, group 1. That means he always forms a plus. That means this is going to be a +1. There's 2 of those, so he's +2 altogether. That means this thing here to add up to 0 is going to be +12. Given that there's 2 of them, that means each individual CR is +6. The one I had to work out was +6. Okay, this is actually using oxidation numbers and actually using them for what they're for. This question tells us that we have to use oxidation numbers, so find them first and then identify what the hell's going on. So if I pick maybe the first one, MgCl2 goes into MgCl2. Okay, let's break it down. Magnesium is an atom. It's on its own. It's not joined up with something else, so it has to add up to 0. Given there's only one thing in there, it's a 0. The next one I can see is chlorine. Chlorine is on its own. It's not charged, so it has to add up to 0. There's 2 equivalent same atoms involved in this. Therefore, if the whole lot adds up to 0, then the individuals have to be 0 as well. So I'm going to give him a 0. Over this side, a little bit more working out. This is going to add up to 0 because there's no charge. Each individual chlorine, I know off the top of my head, is -1. That's the one that jumped out. There's 2 of them. That means over here we need +2. Magnesium is a +2. Now that makes sense because I actually thought I recognised magnesium as a +2 anyway. Now we're going to have a look at how things change. Magnesium starts off at a 0 and goes up to a +2. Magnesium, therefore, has gone up. Magnesium, the oxidation number, has increased. That means that magnesium has oxidized. That is oxidation. If we look at the other one, the chlorine to chloride, it went from 0 to -1. Given it's gone from 0 to -1, that means it's gone down. It's been reduced. So it's reduction. And the oxidation number has gone down. It's reduced. Oh, no space. Yeah. The oxidation number has reduced. Therefore, it's reduction. Now, if I just double check the reading of the question, it says that identify the oxidizing agent. It didn't say identify what was being oxidized. It said oxidizing agent and reducing agent. Therefore, I've got that this was oxidation. The thing that is oxidized is called the reductant. Let's go here. This, therefore, is the reductant or reducing agent. This magnesium made the chlorine reduce. Its job was to make something else reduce. So it's the reductant. I know it can be confusing. Chlorine. The chlorine was reduced, therefore it is the it was reduced, therefore it was the oxidant. The oxidant itself was reduced. It caused something else to oxidize. The thing it caused to oxidize was magnesium. We'll do a few of those later if you don't quite get them. But for those of you who want to have a push on, have a look through on the textbook at page 114 and see if you can get the idea of what's going on there. Alrighty, let's have a look at this one. This one's from a past exam paper. Therefore, it's a good idea of seeing what the jump is or what it's going to look like when you hit the exams. This equation before occurs during the extraction of iron from iron ore. So if I look at this, looking at the 3 methods, Fe2O3, the iron had oxygens attached to it and then it didn't. That means that if I was to pull just that section out, the iron has lost its oxygens. Because it's lost its oxygens, that means that the number of oxygens is down. This is reduction. If this is reduction, then this thing here is called the oxidant. So I'm using the old school method because I saw oxygens involved. If I look at the CO, it turned into CO2. So if I pick out the CO, it turned into CO2. Given that, oxygen got added onto it. That's what we called oxidation. Still do call oxidation. If this was oxidation, then this thing here would be the reductant. Okay, given what I've just worked out, I can see that this thing is the oxidant and this thing is the reductant. So given what it says, CO is the reductant, CO is the reductant. I've ruled these two out. That means it cannot be C, it cannot be D. I'm down to 2. It says here something about the oxidation numbers of the iron. So I'm going to have a look at the oxidation numbers of the iron for the second part, the first part of this question. So if I have a look here, the oxidation number of iron went to 0 because iron was on its own. It's 0 here. Over here, the whole lot had it up to 0. Every oxygen was -2. I had 3 of them. That's -6. That means I need +6. There was 2 of them, so that would be +3. Hopefully you understand that, which means the iron went from +3 to 0. That section's right. And the CO is the reductant. That section's right. This section here is wrong, but that section's right. That means our correct answer for this exam question was A. The next one here, let's have a look. Another past exam paper question. Gives us an idea of what we've got. Let's see if we can make it a little bit bigger so we might be able to read it better. Sulfur dioxide is a chemical. Is this reaction a redox reaction? Explain your answer. Okay, let's go through all of our methods. The one that jumps out to me first of all is the second method, an oil rig cat. I can't, okay, an oil rig cat. I look at this and I can't see any electrons, so I'm probably not going to use that method. Oh, let's go for the original, the OG method. The OG method is where I can see oxygens. Now this is interesting. I can see oxygens here and I can see oxygens here and I can see, so it looks to me initially like I've got H was sitting here and maybe it picked up some oxygen, so maybe that's oxidate. There's an SO3 here and maybe it's gone to SO2. The OG, I'm kind of, yeah, maybe I could justify that. It does say to explain it. But let's just make sure, let's make doubly sure by using oxidation numbers. So if we use oxidation numbers, we can rule out any doubt. And I must say I've got some doubt because this H plus isn't exactly picking up. And this SO3 was part of an ionic. So I'm just going to check with the oxidation numbers. So if I go for the oxidation numbers, if I go for the oxidation numbers method, if I see any changes in oxidation numbers, I'm okay. So let's break them down as we go. So I've got Z. Whoa, I didn't expect that to happen. I've got Zn SO3. This is going to add up to 0. Okay, that's good. I've got, this is going to be a -2. That means I've got -6. Looking at these two, I don't really know any off the top of my head. This changes a lot. Zinc could possibly change. There's got to be some clues in here. It's not in some of the major groups. Zinc isn't in group 1. It's not in group 2. But I have got a clue. This is the only clue I've been given. Therefore, I'm going to go with that zinc was a 2+ version. So I'm going to say, all right, 2+. There's only one of them, +2, which means that the sulfur, +2 -6, I need +4 in here. There's only one of them. So if I go for the sulfur has got a +4, the zinc has got a +2. We go to the next one, H+. H+ is on it as it's going to be +1. Let's go and see what that turned into. The Zn is a 2+, therefore its oxidation number is +2. The next one, SO2, add up to 0. I know off the top of my head. Oxygen, it's -2. There's 2 of them, therefore that adds up to -4. So the S is +4. If I go to the final one, which is water, H2O, that's up to 0. I probably know both of them off the top of my head. Seems reasonable. Here's a -2. Here's a +1. Now, oxidation numbers are going to tell us if anything actually happened here. Let's pick them all out. The Zn was +2 and stayed +2. So that didn't do anything. The S was +4 and stayed +4. Okay, that didn't do anything. Let's look at the oxygens. This oxygen over here was -2, and that's minus stayed. That didn't do anything either. Okay, let's look at the H. H was +1 and stayed +1. So even though initially it looked like oxygens were moving around and the OG, the original method, might have worked, there was some doubt, so we double checked with oxidation numbers, and this is no, not redox. And the reason it's not redox is no oxidation numbers changed. Okay, let's look at one more question, or maybe the second one. In which of the following compounds does the transition metal is an interesting point here to make. So hopefully you'll know off the top of your heads, the transition metal is the Cr there, the Cu there, the Mn there, the Cr in there. Display the lowest oxidation state. So basically what we're looking for is something with an oxidation state that's low. Now, given that it's a metal, they should all be positive. I guess so. The smallest oxidation state I could expect is +1. Let's look out and see if there's any possibilities of it being a +1. If there is, it is. Looking at the first option, if I look at the first option, there's a -2. There's 6 of them. So that means the Cr here is +6. So no, that's way off. That's nowhere near the lowest. S, I don't know S off the top of my head. I'll come back to it if I have to, but let's see if we can avoid it. We can work it out, given it's the only one we're supposed to know. So we can go with what it possibly is, but we'll go there in a minute. If I go for Mn, I know that Cl is a -1. There's 2 of them, so that means the Mn is going to be a 2+. So far I'm comparing +6 with +2. I really want to find a +1. It's the lowest possible. This one's going to take a little bit more work. It adds up to 0. You're at 7. It adds up to 0. I know that's -2. There's 7 of them. That's -14. That's 1. There's 2 of them. That means this means this has to be a +12. He's out. So far, I've ruled out that one at +6 and that one at +6. This one's my leading contender. Now I have to face this one. This one is the one that's the hardest one, but needs to be checked. I was hoping it wouldn't have to be checked, but you know what? Things happen. Cu2 is the one I'm not meant to know. I know that for a fact because I've been asked to find the transition metal. That means the only thing I'm supposed to know in here is that S. So given that that S is one that I'm supposed to be able to predict, it does change a lot, but if we have a look on a periodic table, you might notice it's in group 16. It's underneath oxygen. Therefore, it's most likely to be a -2. If the S is a -2, that's +2. 2 coppers means that each copper is going to be +1. What that means is this is our answer. Exam questions are tricky. They're trying to trick you. They did it again. That's 2 in a row where that was nasty. Which of the following is a redox reaction? Okay, let's see. So once again, I'll look at the methods that I can employ. The first one I'd be looking for every time was an oil recap. Can I see any electrons? Nope, that's a pain. Do any have oxygens moving? Yeah, none of them jump out as oxygens moving. I'm going to have to go quickly as I can. I'm going to have to go with the idea of oxidation numbers. So hopefully you get that the aluminium is going to be a 0. Hopefully you get Chlorine is going to be a 0. Hopefully you get that when it's joined up together, it adds up to 0. Each cell Cl is a -1, that's a -3. That means this must be +3. That's a plus. Yeah, just believe me. So already off the first one, this is redox, the Al changed number and the Cl changed number. Just to clarify, this one started off as +2 and -1. Here, I know that one off the top of my head, -2, 2, no change, no redox. Over here, we've got the same thing. If we break this down, we've got -2 in this one, +1 in that one. Therefore, this has to be +1. The sodium stays as +1. Look, I can go through that one in more detail, but that might do us for past paper questions.